In this lecture, I am going to discuss some numerical example based on per unit representation. In previous lecture, you have seen that per unit value of any physical quantity is given by ratio of its actual value to its base value. Suppose if you want to convert current in per unit system, the current which is given in ampere, and if you want to convert this ampere in per unit system, then how you will convert? You have to divide the actual value of current to its base value. The only condition is the dimension of numerator and dimension of denominator, dimension of actual value and dimension of base value should be same. For example, suppose a machine, 5 ampere current is flowing through the winding of machine, and if you want to convert this 5 ampere in per unit system, then how you will convert? What will be its base value? In previous lecture, I have already discussed about the base value. Base value can be any value, any magnitude can be considered as the base value, provided that its dimension must be same as the actual value. If you want to convert this 5 ampere which is flowing through the winding of machine in per unit system, then actual value will be 5 ampere and base value can be a 5 ampere. Base value can be a 10 ampere and base value can be 1 ampere. It depends on you. What will be its base value? The thing is, the important point is, the dimension of base value should be same as the dimension of actual value, or you can say the per unit system is dimensionless system. The result which you will obtain after the division has no any dimension. So if you will consider 5 ampere as the base value, then in per unit system, this current will be 1 per unit. And if you will consider 10 ampere as the base value, then in per unit system, the answer will be 0.5 per unit. So you can see here that as the base value will change, the answer will change. But both the answer will correct. Just you have to write the current value is 1 per unit on base 5 ampere. The current value is 0.5 per unit on base 10 ampere. Just you have to mention the base value. So there is no any problem, there is no any issue for the selection of base value. You can consider any value as base value, provided that its dimension must be same as the actual value, so that your per unit system will be a dimensionless system. You must remember this, your per unit system is dimensionless system. Now, you can see here, if you will change the base value, then answer will change. So, it is very important to mention on under what base you have calculated this per unit value. It is very important, because without this information, the answer is not logical. Current is 1 per unit. The other question will be, what will be the base value for this calculation? Current is 0.5 per unit. The question will be, what will be the base value for this calculation? So you must mention the base value after the calculation. On which value you have determined this per unit value. So in conclusion, I can say there is no any confusion in the selection of base value. Base value can be of any magnitude, but the dimension of base value must be same as the actual value, so that your per unit system will be dimensionless system. This is the thing. And second thing which I have discussed in the previous lecture is, it is usually recommended, it is usually suggested to consider rating of the machine as the base value. Rating of the machine as the base value. It is just a suggestion. If all students will consider rating of the machine as the base value, then the answer of all students will be same. To make uniformity only, it is suggested to consider rating of the machine as the base value. So you must remember, first thing, you can select any value as the base value. And second thing is the suggestion, is the recommendation, is the rating should be considered as the base value. So that in per unit system, answer remains uniform answer. There will be a uniformity in the answer. And rating of the machine is usually given because your machine is neither purely resistive or nor purely reactive, inductive, capacitive, or you can, in common, you can say neither purely resistive or nor purely reactive. So machine will extract both active and reactive power from the source. So the rating will be given in terms of total power. This is the complex sum of active and reactive power, and for large machine, its unit will be in MVA or in kilovolt ampere, kVA, and voltage. For large machine, it will be in kilovolt, and for a small machine, it will be in volt. Usually machine rating are given in terms of S and V, in terms of complex power and volt. And for resistive load, the rating is usually given in terms of active power and volt. For example, bulb, rating of the bulb, it is given in terms of active power and volt. So for resistive load, the rating may be in terms of power, active power and volt, but for large machine, for alternator, the rating will be in MVA and kilovolt. So the main task is to convert this value. The main task is convert the base value in terms of the rating of the machine. If you will convert base value in terms of the rating of the machine, then it would be very easy to convert conventional unit in per unit, because rating are already available with the machine. So just by using that rating, you can easily convert conventional unit in per unit system. So the main task is to convert the base value in terms of the rating of the machine, so that conventional unit can easily be converted in per unit system. So let us consider the first question. The first question is, convert per unit impedance of the machine in terms of rating. How you will convert? How you will write per unit system of impedance which is given in per unit, and how you will write this per unit value in terms of the rating of the machine. So according to definition of per unit system, the per unit value of impedance will be its actual value to its base value. This is the basic definition of per unit system, and now the task is to convert base value in terms of rating of the machine, so that from the rating you can convert any ohm in per unit. Now, in place of ZB, or ZB can be replaced with the ratio of voltage and current. This is very common. Impedance is the ratio of RMS value of voltage and RMS value of current. So in place of ZB, you can write VB by IB, or you can write IB into VB. Now rating is given in terms of voltage, but not in terms of current. So you have to replace this current in terms of the rating of the machine. And as you know, the complex power is just a product of voltage and current. For single phase system, the complex power is just a product of voltage and current, RMS value of voltage and current. Active power is VI cos phi, reactive power is VI sin phi, but the total power, or you can say the complex power, that includes active and reactive power both, the complex power will be given as the product of V and I. And from this relation, you can replace IB. IB from this equation, IB will be SB by VB. And 1BV, this is already here. So this will be the final expression, and you, after solving this expression, you can get Z actual SB by VB square. So you can see here the per unit impedance of the machine or system can be written in terms of the rating of the machine. Rating of the machine means in terms of S and V. And S and V are available with the machine. So by using that rating, you can convert ohm, you can easily convert ohm in per unit system. So this is very important formula. And you have to remember, you must have the information of this formula, because in analysis of power system, it is often required to convert ohm in per unit. And this formula is not only valid for impedance. This formula is valid for resistance and reactance also, because you are going to convert ohm in per unit. So if you are going to convert resistance value, which is given in ohm in per unit, just in place of Z, you have to write R. Or if you will take the reciprocal of Z, then it will be admittance. And if you will take a reciprocal of this, then it will be actual value of admittance. The unit of admittance is mho or Siemens. And reciprocal of this will be VB square by. So in this way, admittance and admittance will be this. In this way, admittance and impedance can be converted in per unit system simply by using the rating of the machine. And you must remember these two formula. This is very important. And it is often required when you will do the analysis of power system. You will see this formula is very useful for you. It is often required to convert ohm in per unit system. And second thing you must remember, as the base value will change, as the value of SB and VB will change, per unit value of impedance or per unit value of admittance will change. So you must remember this thing also. This is very important. As the base value of change, as the base value will change, per unit value will also change. And it is often required in the analysis of power system. You have to change per unit system from one base to another base. So this is the answer for first question. And you must remember this formula, and it is very useful formula for in the analysis of, or you can say in the fault analysis of power system. It is often required. You have to convert. You will see in next few lecture. It is often required to convert ohm in per unit system. Now, based on this formula, there is one example here. A three-phase alternator rated as 10 MVA and 11 kV. Here rating is given. This is base value of total power, and this one is the base value of voltage. According to recommendation, you have to convert rating as the base value. Now, the winding resistance is 5 ohm, and the task is to convert this 5 ohm in per unit. How you will convert? So here, actual value is 5 ohm, SV is 10 MVA, and VB is 11 kV. So you have to substitute this all value to get answer in per unit system. So you can see from this problem how it is easy to convert ohm in per unit system if you have an idea of rating of the machine. Just using that rating, you can easily convert ohm in per unit system. Let us consider second example. Here 230 kilovolt transmission line has series impedance ohm given and shunt admittance mho or Siemens are given, and using 100 MVA and line voltage as the base value, it is given. You have to convert VB equal to, you have to consider VB equal to 230 kilovolt and SB equal to 100 MVA. And you have to convert this ohm and Siemens or mho in per unit system. So how you will convert? This is the formula. And here SB is 100 MVA and VB is 230 kilovolt and ohm is 4 plus J60. Just you have to substitute all of this data and you will get impedance in per unit system. Similarly, admittance is given, VB is given, SB is given, and after substituting all of this data, you can get admittance value in per unit system. So these are the simple question which can be asked in examination under 1 or 2 marks, and but this is very important how your per unit system is related with MVA and kilovolt, because MVA and kilovolt are usually available, and by using that MVA and kilovolt you can easily convert ohm in per unit system. Now it is often required in power system. When you will do the analysis of power system, it is often required to change its base. Per unit value will be given on one base, and for the analysis purpose it is required to convert it on another base. How you will convert per unit system from one base to another base? As I have stated earlier, as the base value will change, the per unit reactance, impedance or resistance will change. Suppose this is a machine and its reactance is given X1 per unit. Its reactance in per unit is X1. And this per unit value must be on some specific base, because per unit value is completely dependent on the base value. And usually reactance of the machine is given on their rating. Suppose the rating of the machine is S1 and V1, then this value X1 per unit will be on the base value of S1 and V1. And now for the analysis purpose, it is often required to convert, it is often required to find per unit value of the same machine under on some other base. So when the base value will change, then obviously the reactance in per unit value will change. Then what will be the new reactance if you will change the base value of the system? And it is often required when you will do the analysis of power system. So it is very easy to convert. According to the formula, X1 per unit will be actual value of X SB by V1 square, VB square. You can use that formula which you have derived right now. Similarly, this X2 per unit will be actual value of X, and this X2 per unit will be on some new base. So here it will be S2 and V2 square. You must remember the formula. Z per unit will be Z actual into S base divided by VB square. Z per unit. This is the general formula. Z per unit will be Z actual. Z per unit will be Z actual into SB by VB square. Means this per unit value on this base only. This per unit value on this base only. this per unit value on this base only. So now just you have to divide these two quantity, now x2 per unit and x1 per unit. When you will divide these two quantity, what you will get? S2, S1, V1, V2 square. So just by using this formula, you can get new per unit value, or you can say you can get new value of per unit reactance on base S2 and V2. You must remember here, X1 is given, S1 is given, S1 is the base value at which S1 is the base value at which X1 is given. V1 is the base value at which X1 is given. And S2 is the base value at which you are going to calculate new reactance. And V2 is the base value which you are going to calculate. So by using this formula, you can easily calculate base value on some new basis. For example, this is the formula. Here Z, you must remember, here Z2 is the new impedance which you want to calculate, and Z1 per unit is the old impedance which is given in the problem. SB1 and BB1 is the base value at which Z1 per unit is given, and S2 and V2 is the new base value at which you want to calculate new impedance. So you must remember this formula, and by using this formula you can easily convert reactance, impedance or resistance of the system from one base to another base. For example, let us consider this example. A three-phase alternator is rated as this, and on this base the reactance is given this. It means S1 is given, V1 is given, and this reactance is given. Now the question is, calculate per unit value on new base. This is the new base. This is S2 and this one is X2. V2. Now the task is to calculate per unit reactance on new base S2 and V2. How you will calculate? Just you have to use this formula. Reactance which you want to calculate divided by the reactance which is given equal to S2 by S1 into V1 by V2 square. V1 by V2 square. X2 you want to calculate and X1 is given 0.1. S2 is the new base at which you want to calculate the value of reactance, and S1 is given 10 MVA. V1 is the old base voltage at which reactance is given, which is 11, and V2 is the new base at which you want to calculate. So in this way you can find reactance under new base. You can calculate the value of X2 here. So these are the simple problem which I have discussed in this lecture. Now, in next lecture, I will discuss some advantages of per unit system. Why per unit system is desirable? Why per unit system is required for the analysis of power system? What is the benefit? What are the various advantages of power system, per unit system? I will cover these contents in the next lecture.